So according to me, one of the primary inputs for NLP, which is there for which we can talk about decision making, is data again, right? Structured, unstructured data that you can process. The world at this point of time is too early into the real implementation of NLP. So we are probably under 5% of real implementation of what NLP or AI can be done, can be really done, because the data itself is inadequate. So don't feel that this is an abstract terminology, given that you have heard the whole day about so much of data. We have not even scratched the surface of data, and that's the fact. IoT has to still kick in, which will bring in 25% more data, and all that data that we'll see then, including the weather data which is being collected and all, will take you to like 30% or 40% of data. So with all that little understanding that we have of data, by 2020 or 2025, you'll be still around 30-40% of data. So it's not really great that we have achieved a lot of data understanding. First of all, let us be very clear. Everyone feels that we have really discovered everything. What we understand using natural language processing is very little, right? Again, we are just starting at that point where we are starting to implement a few solutions. A lot of trials are happening. A lot of effective projects are done, or POCs are done to implement something which can be called the basis using NLP. Because it's although as rightly mentioned, it has started in 1960s, the first paper has come in there. The real implementation of that has recently started to effectively be used in terms of the finance field. When did it really start? If you look at it, is somewhere when the market really started coming out with a lot of data points, something which is a Facebook, a Twitter, LinkedIn, and all that data needs to be processed. That's when the turning point actually happened, that we will have to use this amount of data, because we cannot visually or by any other methodology understand it. We cannot read through it. So what do we do? So that's where the start happened, that we need to process it, and we need to put up something that will give us some indications. Now, what are those indications? I believe that we are again at a tipping point where we are understanding what the root causes are and what should be the effect. So the cause and effect thing is still being studied for making it a far more intelligent thing. But again, coming back to NLP, everyone is here. We are at the starting point of NLP. There's a lot more to be done. That's my perspective.
Thank you. I will go to Cornel. Haridas, hi. So, you said that also this morning we are understanding that there is a difference between natural language processing and natural language understanding. So can we put it that natural language understanding is based on natural language processing? Or what we actually, or what machines are trying to understand actually from natural languages?
Okay, it is 5 o'clock and we are discussing a new technology. What sir told was the difference between natural language processing, natural language understanding. So I will just take 5 minutes to tell what exactly we are doing, and what exactly, as per my view, and what exactly is the research we have done for the last 6 to 7 years on natural language processing. Now you see, English, Hindi, Marathi, or all the language what we speak, when we speak it with very ease. Because this is a very good way of communication what has been developed. And today, if we can make the machines also understand the language in the same way we human beings understand, that is what will change the world. It will be a paradigm shift. So that is the sphere, that is the area into which we are working. Like in the morning, Dr. Pitroda had mentioned about something about the company in India where he has partnered. It is my company. We are Datawell Analytics, and we are the one. I am one of those 3 guys he talent searched and found out, and with his small ideas, we just started. So NLP is what we stopped. We learned about NLP, and then we started migrating towards natural language understanding.
Thank you. I will just take this to Sobha. I mean, do you subscribe to this, or it's a continuous process, or what do you think? Yeah, it's on. Just speak.
See, the evolution of natural language processing It starts with computational linguistics. And natural language processing was the major technology part of computational linguistics, which is the computational linguistics is the formal theoretical side. Now, NLP in the beginning even had speech recognition in it, and it moved out. Then remained the language technology, natural language understanding, and natural language generation. These three together forms NLP. That's how we in academia...
So NLP is more like an umbrella term?
Yeah, it's umbrella. It comes under AI.
So what are the major, if I just ask you from a perspective of curriculum, what major things you think should fall under this? Like, I mean, is it like how we understand means how we parse the text, how we represent the knowledge, how we represent the semantics? So is it a question of representation or it's a question of, so yeah, please.
It's a question of representation. Of course, it's a representation. There are different levels of representation. It's imparting knowledge to the text. Actually,
can you please elaborate those levels?
Yeah, the levels are, it's a linguistic levels. At the speech level, it is the phonetic level you're doing it. Then at the text level, we have the grammatical level and the semantic level, and to some extent the pragmatic level, where the pragmatic level is the world knowledge.
Okay.
Okay. So at the syntactic level,
like the common sense.
Yes, common sense and other cultural aspects and everything. When it comes to syntactic level, that is a grammar. There are three levels of, that is one at the word level, one at the sentence level, and at the
discourse
level. That is the discourse level. Yeah. Okay. Coming to semantics, even the same three levels are there, where, you know, a word can have two meanings, and depending on the context or the sense.
So sense disambiguation.
Yeah, sense disambiguation. So sense disambiguation plays a major role in natural language understanding, not very much under the language technology. So language technology is actually the tools that you develop to impart the knowledge to the text. For example, part of speech tagger, morphological analyzer, named entity recognizer, and clause boundary identifier, the deep parser. Those are the language technology tools. And when semantic comes, when even the named entity recognition, which is a part of information extraction, it is a semantic, it's at the semantic level. Then you have the anaphora resolution, where you have the connection between two sentences. That's actually natural language understanding. When a system, if the system has to understand, it has to understand the connection between two clauses or two sentences. For example, John went home and he met his mother. The he refers to John. The system has to understand that. Or even in a discourse of two sentences, if you say that, I came to Mumbai, but the plane was late. That but is a connection between the two sentences. So here it is at the discourse level. That is understanding.
So,
if but has to be understood, you have to have the previous sentence, the argument in the previous sentence. That's a challenge.
Yeah, that's a challenge.
It's a very, very
if I say
challenge.
that I saw Mukund with the telescope, you got, I mean, what I mean to say, that I saw Mukund with the telescope, or I saw
the flying planes are dangerous. Flying planes are dangerous. It has two meanings. The one is the flying plane itself it's dangerous.
So ambiguity is inherently...
It's a main problem. Ambiguity is one of the main reason for natural language understanding to
and which is dependent on culture, which is dependent on the demography, the background of people who are dealing with it. Like in India, we have a different set of understanding of certain terms.
So that will come after a certain stage. Most systems which do the natural language processing today, natural language processing, they take, like what ma'am told, they take the words as a token, tokens are tagged, part of speech analysis, and then after that, they try and operate in the syntactic level. Fine, sir. Now, when you are coming to natural language understanding, the whole base is at syntactic level. No, it is not at a syntactic level. At semantic level you do it, by which to each of the word you give a meaning, and that meaning is again tagged with understanding. You try to find out the activity, you build a knowledge base, and on that knowledge base you create an intelligence. And this both are the one which you call understanding.
So is it something that we are trying to mimic human understanding of language?
Yes. By mimicking human understanding of language, what I mean is, so AI, in the AI domain, still natural language understanding is a hard nut to crack. Many people have been doing it. What we did was, we tried this model on a small vocabulary of about 150.
No, my question is, if natural language understanding is a challenge, and if the solution is to closely observe ourselves, that how human understands language,
Yes.
if that is the thing, then I mean, how much of that understanding happened? That means how much we know about ourselves, that how human brain actually interprets language.
So,
Or how it represents, rather.
yes,
Because
actually
it's a
you don't
question
have
of
to go
representation.
to a great level. Only accuracy can be built over a period of time. You
Accuracy-
start, by accuracy I mean, take a small data set, make that data set understand the way you and me talk. Like what ma'am was telling about that conjunction or preposition. If you do that word disambiguation, and then if your entire system can understand that word disambiguation, which leads to understanding of language by the machine, you have achieved to a great extent. But the problem is, with a small vocabulary, you will be able to achieve it. You can make the machine understand. But when it comes to a bigger data set, like 2.8 million words in English Webster Dictionary, so how do you make? Will machine teach this to machine? That is a challenge on which we are now working.
Great. So, if I mean...
Actually,
Yes,
on,
please.
on this topic, I think there are some other ways to look at it, if one is to take the technology into account. We have traditional syntactic-based approaches to language processing. Then, for some time, we had statistical approaches that came in. Today, we have a whole lot of deep learning-based approaches. We have deep learning-based language translation. If you look at Google's language translation, you can put in something in one language.
But
and
how
you can come
different
up-
they are from statistical language processing? Isn't it an extension of that, or it's a new paradigm? I mean, how will you interpret it?
I think when one is looking at statistical language processing, one is not really interpreting anything. It is like assuming that once again there's a machine learning model which will pick up the whole thing. And essentially it is very difficult in such cases to track where exactly the information lies in the system, and it's certainly not deep.
So, which is, by deep you mean it starts from representation. So, you embed the words, or you just take the word with its face value or something?
I'll go with that original problem of AI. What happened was that there was this counter example provided as to what is AI. So the question was, let us suppose that we have a room in which on one side somebody says something in one language, in English, and on the other side it's translated into Chinese. It could also have been the other way around. And the translator does it by looking up some kind of a cookbook, okay, an index. So for every sentence, translator keeps on translating. At the end of the day, using this, it was argued that, well, you have a translation, but do you really have an understanding of
Chinese?
What passed through? Today, when you have Google's translator, how does it operate? It takes pairs of sentences in two languages, one in language A, one in language B. After that, it passes through a deep learning model, which we call a sequence-to-sequence model. So the sequence-to-sequence model will take in, it's like it gulps in one particular body of text, and then you tell it, we have finished feeding in the data, and then it starts spewing out. And this is the way we train it also. Google today uses pretty much this kind of a thing to do language translation. Just before this, Google's language translator was using a statistical model, which was using something like this, but based on notions of things like Markov chains and so on. Fine? So in this case, we are doing a lot of language processing without there being any interpretation of what exactly is passing and no knowledge integration. I see the fundamental problem with this kind of an approach in that you don't have an external knowledge source that you can integrate with this. Today, for a lot of things, we are talking about ontologies. And ontologies, whenever you talk about a domain, the computer itself has no concepts about anything. True. So you need to feed in the concepts in terms of what we term an ontology. Once you feed in an ontology, then the question is, how do you feed in facts based on that ontology? If we are getting a system to reason based on facts, based on ontologies, in my opinion, it is then that you're probably moving towards
understanding,
not otherwise.
So ontologies are essentially knowledge graphs.
Yeah.
And how will you describe them?
Concept graphs.
Concept graphs.
Concept graphs.
Yeah.
Yeah.
So you have hierarchy of concepts
Yeah.
connected
Yeah.
at different level
Yeah.
in n dimension.
Yeah, it will
higher
tell you
dimension.
essentially what are the relations that can occur if you have an entity. A professor will have students.
So, I mean, actually, my
have-
curiosity is whether we human being try to store concepts
Yes.
in that way, or,
Yeah.
I mean, how we learn this? I mean, from observing us, or it's a very synthetic thing that we find this is convenient to manipulate, so we come up with concept graphs, or this is just a question.
I have the feeling it's just convenient because we are so conversant with graphs as a whole, and today we have graph databases.
And we have all the graph mathematics with us.
We have graph mathematics.
Yeah.
We also have very nice graph databases.
Yeah, right.
So
Yeah.
you can just put a natural language interface on top of a graph database which stores the knowledge and then get it to behave as though it really were, an entity with a lot of knowledge which is able to actually conduct a meaningful conversation.
So a convenient way. So this is for convenience. Or do you think there is some connection? Yeah, Sobha is smiling. Maybe she wants to make a point or two.
This sounds very nice when
Because
he
this
says that.
this is on the border of cognitive science.
Yeah, it's at the bottom. And he says that that's the language model that.
Yeah, because
But
understanding
whenever-
leads to cognition.
Yes, understanding leads to cognition, and concept is actually, if you go into cognitive science or cognitive linguistics and you look into it, the way we understand a sentence or way we understand a thing is we assimilate that concept. That's why even if you see the latest educational system, concept-based education. Curriculums are developed using concept-based. So it is a concept that we assimilate, and using that we are understanding the sentence or language or anything that you perceive. So you can see that conceptual graphs are you can reduce a sentence to a conceptual graph.
So I have a bag of text,
But
not words, text.
Text. Bag of text.
Text, yeah, not
Yes.
words. Bag of articles.
Bag of no, don't go to that level of bag of
No,
articles.
I'm just transferring. So the input may be, say, 10,000 articles.
Okay.
And then it got transformed to a knowledge graph, this
Yeah.
conceptual knowledge graph,
Graph.
which is understanding with all its connections made by resolving the anaphora, resolving the ambiguity, resolving this, that, and all these things. And now what next? I mean, my question is where it's leading to.
Oh, if you do all these things and the graph concept is
Yeah.
got.
Say
then you
20 years down the
then-
line, we
then
solve
what-
all these problems of, disambiguation resolving kind
everything-
of thing, don't you?
You mean to say that everything is resolved?
Yeah, so now we have a very well-formed graph of knowledge graph, which is a kind of, we would love to believe that which is a close approximation of human mind,
Yes.
how human stores knowledge.
Replica of that.
Yeah, although we don't know how actually we store. But still, what next?
Next
In
you can
technology.
Go into applications like information extraction or your sentiment analysis, the whole lot of things you can do. So you got that?
So will that help me to actually earn more money? So the question is for you.
That is, if you have insurance, if your language model wants to work on
So
inference.
how the investors can benefit out of it? Once the language technology is in place properly down the line, say 20 years or 10 years down the line now, how, let's hear from Mukund, how he will help us to earn more money.
So it's a very tricky thing. Like at that level of intelligence, when you're speaking about something and your map is already being translated, so it all goes with then your persona, frankly speaking. You know, your persona will be mapped with what you think and how you act, right? It will become extremely intelligent before the fact that as soon as you think it is processed, right? Then you're talking about making a lot of money or making no money because everybody will be having the same thing.
Okay.
Right? So then it will come to a scenario where if you're looking today at people having Bloomberg, all of them have Bloomberg. But only like probably 10-20% of them.
A very personalized version of Bloomberg?
Yes, they use it for their own asset or the companies of interest, but they have the same data. So one of the questions which I earlier spoken about was having generic data. Like Bloomberg is generic data. If you say everyone in the world has the same data, but only 10-20% of the traders would make money, right? Because they see data points differently. They make sense out of those data points differently. So when your own persona is got uploaded using all the memory map that we are talking about.
Kind of brain mapping.
It is going to be brain mapping because every behavior of yours would be essentially translated, and then it knows using AI, which will become the next level as what should be the action point, right? So it will trigger those things. So the moment you say, how is the market today, you need not say beyond that because it knows that you're probably heavily invested in IT and in banking, and then it will give you the news about it. But what will be the problem will be, it will be limited to whatever is your mind map. It cannot go beyond that because it has no understanding of that space of
So
yours.
there is a saturation.
There will always be a limitation to intelligence in these spaces where it doesn't have a mind map.
Okay.
It can never understand what I'm thinking about. So that part of the human being, which is unknown, which we discover ourselves, will never be there. So no NLP can process that.
Or NLU.
NLU even, because it doesn't have that understanding.
Sir, may I add to
Yeah, please. Just
now what Dr. Mukund told, NLU in this case, say what you told first, sir, let it be a bag of text. So now when NLU will process this data, NLU will take into consideration the relationships, the common sense, the understanding, and after that only it will throw result. So that result which is based will be very near to what you and me will be doing by sifting through that data manually.
No, that is well taken. But his concern is that you and I both will have this, rely on the same conclusion or same data. So,
Sir, today also, the same data is the one which both of us see. Let it be from ET, Bloomberg, and the type of investment pattern is different. We both are not investing in the same way.
you want to comment on this?
So, the whole point is always going to be in terms of when data points are going to be common and personas also map up.
First class.
Yes.
Then you'll have the same problem. Right? Now, if...
So good old human being will
Exactly.
start
If I'm
exercising.
his friend and we both usually trade together in the same manner, in the same financial sectors, our memory maps as far as money is concerned will be same, absolutely the same.
So it's basically, isn't that we are back to square one?
Like, yeah, it will be back to square one because that will be the limitation of whatever is getting mapped as the mind map, right? So
Yeah.
all the tree, once you put in all those articles and whatever comes out as a structure which is mapped, at the end of which is the golden coins which you are going to make, they'll traverse through the same chain. So you'll have the same tokens, you'll have the same understanding, you'll have the same implementation. So your whole map will be the same between the two people. So there
I would
you
like
subscribe to this?
I would actually like to pull the discussion back a bit in the sense that, I'm not looking too far out into the future.
Okay.
Let's rather plant our feet into what is available today. I work in this unit where we provide data analytics services. Now, very frequently, and more this has become the point, very high-level managers come up with the request, I do not want to pass through an intermediary. I want to directly probe the system and get all the analytic outputs that I want at the time when I want it. Today, if you look at Hadoop data lake-based infrastructure, it is actually possible to run a query, get all the data together, and answer a business analytics question that way. But you do need intermediaries. So the first thing that you try to do is put an NLP layer on top of that. Today, however, what happens is that as a first approximation, that becomes a way too complex problem. So how do we solve it? Today, we solve it by the following. We keep a track of what are the common questions that managers are supposed to ask. What are the kind of things that they typically ask for? Let's mine them before and put them into some kind of a local database, and let me put a natural language-based interface to that local database.
For querying.
For querying. This is my level 1. Level 2, you want more information. I just talked about, having an ontology and a knowledge graph. I would say you should add that. In that case, what would happen is, instead of that intermediate mining being required, you would then be able to get this person's query in natural language, directly translate it into let us say, Spark query, or let's say a Sparkle query if you have a graph database.
And get back the answer in the same language.
Get the answer in whatever way that person wants. So I think in terms of actually looking at, something that makes a lot of commercial sense, this is way and probably the path things are taking already.
I would like to say something. So he said that there is a layer of NLP. That layer is the hardest layer where you have to bring in the natural language processing.
No, but he also mentioned that there are different granularities. His level 1 is just a kind of what is available today, like to understand.
But it is, to some extent, the other part is also available in natural language processing.
Let me explain. This kind of interface is usually made kind of easy by the common query mechanisms that are there. You will find out that most of the NLP tools that are available today from cloud service providers will allow you to query for intent. You can provide a sentence and say, what is the intent behind this? So if I have an intent, and if I can identify all the entities which are queried associated with the intent, then I can translate it into a database query. If I have a relational database, then I am talking about.
Yeah, I mean, so that is, quite apparent.
But coming to intent, how do you identify an intent? Exactly. That's the main problem.
Yeah. So that's the hardest problem, essentially. So that opens up the Pandora box. Yes. That how you represent it, how you understand it, how you identify this is the intent, how you measure it, is there how to measure the intent or...
the intent itself, what is it?
There is one problem here.
Yeah.
Intent also is made available by almost every cloud service provider. Based on what? We know that this is a difficult problem, but based on what? Based on, once again, that, neural network based or deep learning based approach.
No,
Today, all of them are doing intent classification. So what they do is, they do an embedding of the text, followed by that.
But the moment you tag it as a classification problem, so you know how many classes are there, and you are just trying to put them into boxes. So at present, that is fine. But I just would like to ask Angshuman that do you think this NLP layer that we just got to know will help you to solve some of the marketing and retail problems?
Yeah, so hi, this is Angshuman. I work for, just 1 second, I'll just talk about a little bit of my background so that I'll connect to the question. So I work for Target. It's the second largest supermarket in US, $72 billion company. And so I'll give a couple of examples from retail and marketing to exactly see how we are using it. And probably I don't need to introduce Target because in the first session, somebody introduced Target saying that, 2012 Target predicted that some lady has become pregnant even before their family knew. So that is the kind of work that Target is to do in 2012. And so I'll share a couple of examples what we are doing currently, and where the actually technology is heading, especially as I see in US, the tech, retail, and finance industry are the most advanced in this kind of technologies. So for the first example, before I speak, I would like to ask, how many of you invest in the markets, stock markets? Please raise your hands, please. Almost everyone, right? And any one of you have invested in the market recently in last, say, 1 month or last week or so? Yeah? So can any of you, tell based on what you made that investment decision, either to buy or sell? Anyone? The latest decision that you made to buy or sell, how did you make that decision? Anyone? So basically fundamentally use some past historical numbers to calculate some trend or something and made the analysis. But did you also use some news article or something like that? Saying that, something happened in China or something happened in US or this happened to our GDP or something, right? And there you are reading the article and making a decision, right? No. Can you use any tool there? No?
So here you fits in.
There exactly where this session, fits in. Where we are talking about NLP. Because traditional, all the financial analysis that we mostly do, we use numbers, right? So numbers computers are good with, and we have a lot of tools. But we have so much of valuable text data, which also impacts the decision, and we don't have any tool to do that. And that is exactly why probably we are having this session here, where we are talking about natural language processing, which is fundamentally language in the form of text, or even in the future is going towards voice. So, one of the work I did at Star and even at Target we do. So the text data primarily can come from all your news sources. And kindly, how many of you use, Facebook?
The other
Almost.
question, how many of you don't use Facebook?
Oh, that will be easier to answer, right? So, so that is also a very rich source of data, right? Facebook or Twitter. And especially for the branding side of it. So Target has $20 billion brands. And Star also had some really, big brands like Star Sports, Star Plus, Hotstar and all. And we needed to understand how those brands are performing on real time. So for example, some match is going on, right? Kindly, football World Cup is going on. So I assume most of you must be watching, right? So there, if the channel can know in the real time what are the things that people are talking about on the social media and provide some ad or something in the real time based on that, that becomes really interesting, right? So the sentiment analysis and social media data analysis is one area where I think marketing and even for financial products for your investment. Yes, sir. Please tell your name and then you can ask.
So I have a question, and you said that there can be a tool that can be used to predict the market as well as the investment decisions.
Exactly.
There is one question. Say for example, there is one stock that is known as Mahanagar Gas.
Mm-hmm.
So it's trading close to around 14 times price to 100 forward earnings.
Okay.
So there are analysts who have predicted that it will go up till actually in maybe FY19 it should trade close to
Mm-hmm.
18 times, and then the price target is 1010. The current market price is around 825.
Right.
So will the machine be able to do such kind of analysis going forward as well?
So the machine, see, it's one thing I want to clarify based on whatever session I attended, most of the sessions from the morning. So machine does some of the things, right? But machine doesn't do anything. Machine doesn't do everything, right? So there is no machine which is doing it. Machine is helping you to make things scalable, right? In the form of processing, storage, and everything. But there is some person who is putting that algorithm together.
Yeah, but I need to intervene here.
Yes.
Maybe this is not exactly what we are heading, but I just can answer on his behalf. We can say that NLP components can complement the numerical component.
Right, exactly.
So arrive you to a better result.
Exactly.
That's it.
So kindly you're using only numbers. You can add the text, news,
so
everything
is it,
together.
Thank you.
Yeah.
So is it the same case for Heckyl that, I mean, you managed to capture this immense power of NLP so far you have with you?
So what we started with was news data analytics, right? That was our first product which got launched. So we go to almost 1.5 million data sources, which includes the web, the regulators, and all the corporates. And we capture the data from there and we process it in real time. So one of the complexities, it is not really a layer. It is by itself a stack which is so complex, and it is handcrafted and handwritten rules, which starts with the dictionary, the simplest terminology so that we can all understand.
So you mean no machine learning?
Sorry?
You mean no machine learning, but human learning has been captured in form of rules?
So yes, so
Which is anyway more efficient, that we realize.
It's a three-layer stack which we have done. One which starts with the simplest thing, which is dictionary. Good is positive, bad is negative, as simple as that. And then there are thousands of words, right? All the dictionaries captured essentially and put into context. And then comes the complex business rules, which are, you would say, schematic in nature, which would bring out the relationship, like when an and is used or when a but is used. So it's very simple according to English, but it is very complex according to the financial language terminology. And then there is which sector it is, where is the news coming from. So we have got around 256 dimensions which are there.
Oh, okay.
Like which region it is coming from, who is writing it, what is the source, what is the domain. So everything is mapped essentially.
So you have
to
an
that layer.
exhaustive idea about the parameters that might influence this.
Exactly. So there are influences which
And
are
that is
there.
manually developed.
That is manually handcrafted.
Handcrafted,
Right.
okay.
And then this gets into the AI layer, where we put in algorithms, and all this is mixed inside with the statement that comes in, and then comes the sentiment. Now, 7 years have gone inside to build this algorithm. We are one of the best in the world ranked. But understand the efficiency of NLP is only around 76 to 78%, right? So the failure rate is still around 24%. And we are the best, I'm talking about. If you have to pick up 5 best in the world in terms of sentiment analytics, we are there, right?
But we just have one team, the claim is that the accuracy is 100%. Yeah.
I will just, contextually we will have to analyze it.
Yeah.
When I told that, yes, we did that Facebook Baby contest, which I will be, if I get time from the organizers, I will be presenting it. Facebook Baby contest was natural language understanding. They told you will not use any statistical tool, a vocabulary of about 400, 20 data sets with 1 million questions, and then they told, please answer this. So there were people who used natural language processing, natural understanding. We also used natural language understanding. But in our case, what we did was, we mapped the whole thing to actual what is happening in the world. Like if Fred is having apple in his hand. So we made the machine understand who is Fred, what is apple, what is noun, what is pronoun, the way in the school our teachers and our parents taught us when we were growing. So to a limited vocabulary, we did that. And to our surprise, we found that we were evaluated 20 by 20 with 100% accuracy. And we are still the only one in the world to have done it. But yes, still what he is telling is still a challenge. I mean, how do you build?
So the question is limited vocabulary versus a real set of financial vocabulary, financial domain of understanding all the internal tricks of finance and other things getting embedded. Yes.
Absolutely. Like we have written more than 100,000 business rules, and these are extremely complex, written by business specialists, right? They are from the domain, right? And we continuously keep on writing them. See, first of all, this is limited only to English primarily, because if you look at the other box of the other languages which are existing, it's very difficult because language translation is a different world, as he has properly explained.
True.
I don't think I can add another word to it.
True.
It's perfect.
Very compact.
And it is still not reached that level. Like Mandarin language cannot be understood still, right? One of the biggest languages spoken, right? To a large extent, I would say 90% the translation is good, 90%, right? But when you look at the translated English, a person still understands it and makes meaning out of it, but you put it as is inside the NLP, it will probably process it differently. That's the fear factor. So as of today, we are processing more than 10 million articles every day in real time. And when you talk about real time, it is very simplistically a multi-threaded model. Everything is broken down and parallelly processed. And for them, it is combined back again inside, given a sentiment score. And so who has written it, where it has come from, whom is it pertaining to, what are the keywords, what is the cumulative knowledge that it is carrying, what is the total sentiment from that sector. So everything is calculated in a second and then given it out. So the complexity is extremely high.
True, but so what, if I correctly understand that, I understood that the business rules, underlying business rules that you mentioned about 1,500.
100,000 more.
100,000 more, okay. Okay, has been written by the business experts.
Absolutely.
It's not a kind of rule mining technique from the texts that you dump some cases for last 100 years from the case studies of different business and also the manuals and the machine learning sometimes claim this kind of stuffs are already up around in the air, that I mean we can mine rules, associations and understand conjectures, and we can create hypotheses, and then we can even find a proof to that hypothesis or something like that. But you still rather subscribe that business experts are essentially doing the real work.
Absolutely.
I have a question for you, and that is, even if it is 70%, is it not possible to use averaging over a number of such sensors to get an actual feel that should be?
Oh yeah, absolutely. So very important question. When you go to certain sectors, like let us pick up an FMCG sector, which is very vibrant, fast moving, right? If you look at the average of 5 days, you will come to know how the sentiment score is. Means where it will average out. Like whatever happens on Monday, how it will affect the market. But if you go to a heavy industry, a steel industry or something, you'll have to probably take an average of 3 months or 100 days DMA on the sentiment itself to come to the linearity. We can actually, to a 70-80% of accuracy level, map it with the price movement also. But it is possible. Absolutely, it is possible. But if
So
your
speed
rules
of
are,
the movement.
it's not done in real time. Otherwise, I would not be here. I would be speaking from Mars. Told Elon Musk to shuttle me out separately. And this question came to me 7 years back, that if you give me the perfect code, I said, sir, then I'll be sitting in a 16-inch sealed vault, making a few $1 billion, and then destroying my code and sitting peacefully in Maldives or Mauritius somewhere. So that's not possible.
Well, I would like to say something about sentiment analysis, which we have been working for the last couple of years, and we have a proper system which is predicting different. Before that, I like to say about the language trends that we have. Earlier, we had normal text, where it is completely following the grammatical rules of the language. Later, when computer-mediated communication started,
Social media.
not social media. When the LAN started, there were this email kind of thing going on. So then we evolved a type of language. Then came the technology-mediated communication. That is the present-day thing, the Twitter, which is reducing it to 180 characters and all. So the language itself is changing. So if you want to work on natural language processing, there are 3 levels of language that you have.
So what
One
is natural?
All are natural because it is generated by human brains.
All
So
3.
All 3 are natural, but this is the language variation of the present day. Earlier, it used to be socio-economic and political thing that used to change the language, but now it is technology-mediated changes that
And we
is
have
happening.
to accept it.
That we have to accept it. Tomorrow, it is going to be visual plus emoticons plus everything in the language. So you have proper linguistic rules will not work on any of this new generation language, new variation of language. So statistical method is what we have, statistical or machine learning. An underlying factor is probability. That's what we are using now for Twitter or Facebook or the present day language, as well as the old, our traditional text. When it comes to sentiment analysis, the hybrid approach is the best approach to have a precision of around 89% and a recall of 80%. Normally, evaluation is done under precision and recall, which Prasenjit knows very well. He is the one who does evaluation a lot for all NLP systems in India. So precision and recall, and which gives a F measure. So precision can go very high with machine learning, as you said, that handcrafted rules. But machine learning is the one which gives you recall. So the hybrid approach is the best approach to get a very good, precision recall.
Absolutely.
And a good F score.
Absolutely.
Okay.
So a good mix of human intelligence and artificial intelligence.
Yes. So handcrafted rules are needed. From the handcrafted rules, you kind of find out the features for machine learning. And that is what is used for machine learning. And that will give you a good recall.
I will just come back to you.
No, just one more thing.
Yeah.
The new machine translation systems that all the three MNCs have come out, RNN, okay? That is, as he said, it is neural. The output from that has to go into a post-editing system. That is going to be completely linguistically driven system. Otherwise, though you see that it is giving you good result and all, we are the evaluators for many of the machine translation system. It's working only with 45 to 50% for a general domain. It may work for 75% for a specific narrow domain. So it's all going to be domain specific. Any NLP system, if you want to, if the system wants to perform at a higher level, it has to be domain or subdomain specific.
Do you know any such thing in this domain, marketing, finance? I mean,
We work on sentiment analysis at this business domain.
but you think this is an important
Yes.
domain to explore, because
Yes,
anyway,
of course.
Heckyl
There
is
are so
working
many,
on that.
so many areas in this, like the company merging and other information. You to identify that, then insurance, where there is a lapse and where there are a lot of fraud happening in the insurance. If you want to cull it out, you need information extraction systems. And named entity, what is happening, where, when, what? That is the question that we ask
So
whenever
you need
we
to get the entities, you need to connect them.
Yeah, you have to
Absolutely.
connect them. The
And then you make
relation
sense
between
out
the
of them.
entities, relation between the entities, then, what time it happened, which place it happened, and across a document, a same entity can be represented in various forms.
True.
Similarity between documents are required because the same document can occur in various forms in various places. So you have to call out the documents which are talking about the same factor, same focus. So focus identified and then similarity. All these we use both, machine learning and linguistic. Hybrid systems are giving the...
So hybrid system is a very important takeaway. I mean, from this part of the discussion. But I will go to Angshuman again about his take, your take.
Yeah, exactly. So I was going to mention there. So we exactly use something very similar when I was in STAR. So we wanted to analyze, what people are talking on social media and how to summarize that as to how our brands or, shows are performing. So they are one of the best tools for social CRM analysis is Radian 6 by Salesforce. But unfortunately, that tool will do the analysis like, Mr. Mukund said that, it has its own dictionary, good and bad, and based on that create the sentiment and give me the results, right? But suppose I have a show called, say, Saath Nivana Sathiya or something. So somebody calls it Sathiya, somebody calls it Saath Nivana Sathiya. Somebody just mentioned the character name of the show, say Gopi Bahu. But all are actually relating to a particular serial on Star Plus, right? So somebody has to manually create the dictionary or the tagging or meta tagging to say that all of these things are referring to something where that human intervention is very important. And then you combine it to the scalability of the software, say a Salesforce, and that can, do the work much better. Just to add to that where, some of the things that we are seeing, how it goes even more advanced, maybe one or two examples I'll just try to quote. So all of you have heard about Google Home or Amazon Echo device. Any of you own it? Google Home or Amazon Echo? You own it? So this is basically a, voice-based system, right?
Alexa.
Like Alexa is the technology, software part of it. Echo is the device. So the device stays there. You tell something, okay, order this book from, Amazon or something. Now this is particular one field. I think this is going to change not just one industry, but most of the industries in a very fundamental way, right?
How?
How, exactly. So, for example, currently, if you want to shop for something, anything you want to purchase, how will you purchase? Suppose you want to purchase anything, how will you do it?
Usually I search or sometimes get recommended.
Okay, so most usual way might be you go to some shop and buy it offline, or if you are going online, you'll search, or you go to the website, it recommends you something, right? Now, fundamentally, how this is going to change is, so with that Google, so Amazon has the Echo product, right? So Amazon is a competitor to Target in US. So we'll not go with, say, Amazon Echo, we'll go with Google Home. And in Google Home, you don't need to tell that, okay, suppose you probably use a Dove soap, right? And suppose kindly you go and search for the Dove soap and order it. Or you tell your, offline retailer that get me, or you go and purchase it. But how it is going to work is that, suppose if you want to have some tea at home, and you want a particular type of tea, with, little less sugar and maybe some ginger or something, do you go and tell your wife or mother or cook every day? No, right? We don't do that, right? So our cook or wife or mother, whoever...
I usually make my own tea.
Achha, you make your own tea, but whoever, goes to someone else or you go to a shop, they might know and they customize it to as per your taste and preference. So won't it be wonderful if the, AI system or NLP that we are talking about can do it on our behalf? So what's going to happen there is basically I'll just say, I don't even say I want a Dove soap. I just tell I want soap or diaper, right? And the software knows, so Target probably will give my past purchase data, and the software knows that, okay, I purchased this soap 4 units per month from this shop, right? And on the fly, it can also calculate which is the nearest store, what are the prices at different places, right? So you don't have to tell your brand, you don't have to tell your quantity. So from the text, we are getting into voice, which is more natural, like we are here talking, right? We're not writing to each other some text, or neither we are, talking in numbers. We're talking to each other, conversational, and that's where, things are going to be in retail, and I can see the same thing can probably happen for finance also, right? Because the technology remains same fundamentally. I say, okay, I want some mutual fund product where I can get 10% return without much risk, right? And if the device can select which particular product fits that requirement and automatically goes online and orders on your behalf, that would be really wonderful. And in retail, we say this is going to be a game changer, and same thing probably can happen for finance as well. Yep.
So there are two challenges. One, what was being told about language, what Mukund was talking about language. Now you see, NLP, NLU is developing towards that area where language agnostic internal knowledge representation will be gained in the future, very soon. Two, all these engines, let it be NLP, NLU based engine, will have some kind of learning facts built into it. So the day you have these things, you are able to build facts of learning into your engine. Two, if it is language agnostic, then many challenges are going to be overcome.
Can be addressed. Thank you.
I'll just like to add 3 points which are very critical from NLP perspective. One is that human beings are becoming more intelligent. So essentially, when we talk about AI, which NLP is a part of AI for decision making, since we are becoming more intelligent, the data points are going to actually switch in terms of what decisions we are going to make. So it cannot be like what it is today. Second thing is that the data points themselves are changing, right? You have to take into account that the number of data points that will keep on coming. So NLP, when it is translated into an action at the AI level, will take into account multiple constituents. It will not be only one language that is translated will determine everything. Intelligence means applying multiple dimensions together and then taking a decision. That's how you'll make a smart application, right? So that is going to change. And third thing, which is more important, is at this point of time, whatever we know, we are designing everything on the basis of that. We don't know about tomorrow, right? That is the biggest unknown. 10 years back, there's nothing called as drones and all those things. Suddenly, they are all there today. So let us all be aware of the fact that there's tomorrow something that might come tomorrow, which is going to be more than what we understand today. So these are the 3 things which, according to me, are important.
Thank you, Mukund. So if I summarize the discussion, there are very interesting things came up. One major takeaway, given the current state-of-the-art natural language understanding technologies available, we need a very good mix of human intelligence, and humans are getting more intelligent, as you said. But I'm afraid this morning I just got to know that humans are getting more dumb as business intelligence is making them, forgetting them, the phone numbers, this and that, so memory component is getting less and less. But the argument will still exist. But so this is one important takeaway that current NLP technology or NLU technology supplemented or complemented rather, complemented with human intelligence can do really good miracle, which these two guys sitting on my both sides, they actually did so. And this morning there was also another apprehension that written text will stop to exist, will cease to exist in another 50 years. And what Sobha also mentioned, that the future language could be emoticons, this and that. I mean, the definition of natural language is not what we used to understand when we were in our schools. So there are different layers of natural languages. So language, if you consider it as a protocol to communicate, and which comes up naturally, have now many faces. So might be speech, so it might be spoken languages, and everything via my artificial assistant from Target or from Amazon or from Google will be conversing with me through a voice, through the voice media. So on that note, let's thank all the panelists again for their very insightful comments and discussion. I welcome you.